Okay, using everything we've learned, we're going to look at how we can sketch graphs. So here are some things we're going to use when we're sketching a graph. First, we'll find the domain of the function. Okay, then we'll find the zeros, because those will be the x-intercepts. So we'll set the function equal to 0 and solve. So those will be the x-intercepts. And f of 0 will be the y-intercept. Okay, we'll find the asymptotes, both the vertical ones and the horizontal. We'll find where it's positive and negative, so we'll set f of x. Well, you've already found the zeros, so we'll make a sign diagram. We'll find where it's positive and negative. We'll find where it's increasing and decreasing, so we'll find out where, sorry, not the second, the first derivative is positive or negative. For concave down, we'll find where the second derivative is positive or negative. And then we'll find the values for the critical points or the inflection points. Okay, so let's use this process with a relatively simple one, and in the next video we'll do some more complex examples. So first we want the domain. So here our f of x is x squared minus 4x plus 3, which is a polynomial, so our domain is all real numbers. Okay, next we're going to look for the zeros and f of 0. So f of 0, if we plug in 0, is 3. And if we set x squared minus 4x plus 3 equal to 0, well, this factors as x minus 3 and x minus 1. So we get the zeros are x equals 1 and x equals 3. So we have x-intercepts at 1 and 3. So just by even what we've done so far, let's start sketching a graph of our parabola. Okay, so we know the zeros are at 1 and 3, and we know f of 0 is 3, so our y-intercept is 3. So number 3 asks for the asymptotes. Now this is a polynomial, so we actually have no asymptotes. So we don't have any vertical ones because there's no place, we don't have a denominator, so there's no place where it's going to 0, or sorry, going to infinity or well, the denominator would be 0, but our limits would be going to infinity or negative infinity. And for the horizontal ones, if we looked at the limit as x goes to infinity or the limit as x goes to negative infinity, in both cases here they're going to infinity. So we don't have a horizontal asymptote. Okay, so 4 asks where is our graph positive and where is it negative. So to do that, you're going to make a sign chart for your original function, and we're going to put the zeros, 1 and 3, and we're going to test points on each part. So at 0 we know it's positive. If we put in 2, we would have 4 minus 8, which would be negative 4, plus 3 would be negative 1, so we'd get a negative. And if we put in something like 4, we would have 16 minus 16 plus 3, which would be positive 3. Okay, so we know it's f of x is positive from negative infinity to 1 and from 3 to infinity, and f of x is negative from 1 to 3. So between our two zeros, we're going to be down below the x-axis, and before there and after that we're going to be above the x-axis, which is good because we know off to either side it's going up toward infinity. Okay, next we want to know where it's increasing and decreasing. So we're going to need the second derivative. Sorry, the first derivative. And the first derivative is 2x minus 4. So if we set that equal to 0, we're going to get x equals 2. So we're going to make a first derivative sign chart. and we'll plug these values, test values, into the derivative. So if we plug in 0, we're going to get a negative. If we plug in something like 3, we're going to get a positive. So f of x is decreasing from negative infinity to 2, and f of x is increasing from 2 to infinity. Now, since we're going from decreasing to increasing, we know we're going to have a minimum of something at x equals 2. Now, to get the actual minimum value, we're going to plug 2 into our original function, which is going to give us 4 minus 8 is negative 4 plus 3 is negative 1. So we've got a minimum. So we've got the point 2, negative 1. And that's our minimum point. And from here, since it's just a parabola, you could really sketch the parabola. To finish our process, next we would look for concavity and any inflection points. Here, our second derivative is just 2, which means we're always concave up. So we'd say f of x is concave up from negative infinity to infinity, and we have no inflection points.